हो गया
हाँ
तो वो रिवर्स बायस के केस में उसके अक्रॉस वोल्टेज अप्रोक्सीमेटली क्लोज टू जीरो रहता है ना, करंट बहुत ज्यादा बढ़ जाता है ना।
जीरो का रहता है वोल्टेज। आईवी कैरेक्टरिस्टिक ड्रॉ करो जिनर डायोड का, उसमें वोल्टेज जीरो कहाँ है? ओके
जीरो नहीं है लेकिन क्लोज टू।
जीरो जो वोल्टेज तो वीजेड होता है, वीजेड होता है। अगर उसके अक्रॉस जो ओपन सर्किट में वोल्टेज वीजेड से ज्यादा है तो वोल्टेज वीजेड आता है, जीरो थोड़ी आता है। आईवी कैरेक्टरिस्टिक नहीं पता आपको पी जंक्शन की मैंने कितनी बार ड्रॉ करी है? okay? ये वोल्टेज है, जीरो का है, यहाँ पे आके फिक्स हो जाता है वोल्टेज। और करंट करंट मिनिमम से मैक्सिमम करंट फ्लो करता है।
यस सर, सॉरी सर।
हम्म,
तो उसमें वो मतलब करंट पास करेगा और जब सेकेंड साइकिल आएगी नेगेटिव में तब वो फॉरवर्ड बायस होगा और
हाँ
जो वेव होगी वही हमें मिलेगी ना।
हाँ बिल्कुल, क्योंकि वहां पे वोल्टेज ड्रॉप जीरो हो जाएगा। ओके, तो जो वोल्टेज मिलना है वो सारा का सारा उधर ही मिलेगा। ओके,
थैंक यू।
जस्ट 1 मिनट। So why students are not coming? Board is clear?
Yes, sir.
We'll start. So we'll see today Zener diode as a regulator. Okay, we'll see Zener diode as a regulator. So this is your circuit of Zener diode. Okay. Here you have a Zener diode. Okay, and say and here you have resistance. For example, I'm taking this. This is a 10 volt. Okay, and this resistance is 40 ohm, and RL is your 100 ohm, and Zener voltage is given as 6 volt. Okay, okay. So this is the your Zener diode regulating circuit. Okay, so always whenever Zener diode is working as a regulator, you find this kind of circuit. Now if you see carefully this circuit, okay, here some current will be flowing through resistance IR, and this current will distribute. Okay, this will go to the load, if I call this load. Okay, and some current will go to Zener. Okay, so your IR is always equals to your IZ plus IL. Now in this kind of circuit, okay, the first thing is to check whether Zener diode is conducting or not conducting. That means the voltage across Zener diode is should be minimum 6 volt. Okay, according to the given Zener voltage. So the minimum voltage here should be Zener, BZ. So if it is voltage is across this diode is equal to or greater than this 6 volt, okay, then your diode will be conducting, and you can replace it by a battery. So for example, this particular case, they asking calculate the power dissipated in Zener diode. Okay, calculate.
Sir, so can you repeat
power,
the last statement?
yeah, calculate the power dissipated. okay, in Zener diode. So I was discussing, this is your user circuit. Okay, so if this diode, if this voltage across the diode is 6 volt or greater than 6 volt, then this diode will be in conducting state. And in that case, you can replace this by a 6 volt battery. Okay, so now we have to check. So for checking, what we can do, we can open this circuit. Okay, here we have 100 ohm resistance. So just you make Zener open and check it how much voltage is coming here. This voltage is equal to this voltage. Okay, so now you have 10 volt. If you calculate V open, so V open, okay, here V open is how much? Your total 10 volt, resistance is your 140 ohm, and you want to calculate this one, so you have to multiply by 100. Okay, so this become 1000 divided by 140. Okay, so how much is coming here? Is approximately 7 point something. Okay, that means this is a greater than 6 volt, isn't it?
Sir, board is not visible.
Board is not
Can you repeat?
7.1. Yes, 1 minute. बोर्ड नीचे जा रहा है कि साफ नहीं है?
जा रहा है.
नीचे जा रहा है. ओके. Okay. So just give me 1 minute. Okay. So can you see now? See, I want to find whether Zener diode is working condition or is conducting or not conducting. Okay. If so, I am calculating what is the voltage across this Zener diode. Okay. So in order to calculate this voltage, okay. So I am calculating. I have removed the diode. I am calculating this V open, and this V open is coming around 7 point something, and is greater than 6, isn't it? Reply. Is greater than 6 or not?
Yes, sir.
Yes, sir.
Yes, sir.
So if it is greater than 6, that means my diode is conducting. Okay. So once I checked, I'm to make sure whether diode is conducting or not conducting. So I found V open is greater than 6 volt. Given Zener voltage, so it is conducting. Now I can replace this diode by a 6 volt battery. Okay. Now when the voltage is fixed, 6 volt is fixed, automatically voltage here also fixed. Okay, and when this voltage is fixed, this voltage is fixed, this voltage is also fixed, isn't it? Okay, now if I want to calculate voltage across this R VR, if I call this VR, so my VR will be how much? Okay, so if I apply KVL here, so I have 10. Okay, say this is VR, this will be VR, and this V plus 6 equals to 0. So VR is how much? VR is now 10 minus 6, 4 volt. Okay, so once this voltage is fixed, once it's conducting, this voltage is fixed. Now this cannot change, and this is also fixed, 6 volt. Now this fixed, that means this is also fixed. Okay, now I can find how much current is flowing, this current, how much current is flowing IR. Okay, so I can now calculate the current IR, which is equals to how much? VR upon 40 ohm. Okay, VR is 4 volt, this is 40, this become 1 by 10. 1 by 10 means how much? This become your 0.1 ampere, that is 100 milliampere. Okay, now in the question it is they are asking calculate the power dissipated in Zener diode. So the power dissipated in Zener diode is given by PZ, okay, equals to IZ, VZ. So VZ we already know, this 6 volt. Now I need to calculate IZ. Okay, so in order to calculate IZ, how can I calculate IZ? How can I calculate IZ? Please tell me.
IR is equal to IZ plus IL.
Okay, so you have IZ equals to IR equal to IZ plus IR. So IR already I have. Okay, what is the value of IL? How can I calculate IL? This is 100 ohm resistance, and voltage across IL is how much? 6. Very
Six.
good. Okay, so this become 0.06 ampere. That is become 60 milliampere. Okay, now you want IZ. So IZ is nothing. IR minus IL, that is 100 minus 60, that is 40 milliampere, isn't it? Okay, now you know VZ, you know IZ, you can find how much voltage is there. IZ is 40 milliampere and VZ is 6, so this become 240 milliwatt. Okay, any question? Any question? No question, then I can move to next problem. Okay. Now the next problem, okay, they given me a V input. Okay, here we have a resistance. Okay, and this resistance value is 1 kilo ohm, and this is given 16 volts. Okay, and this diode is here VZ, and I have been given the value of is 1.2 kilo ohm. Okay, and the general voltage is given 10 volt. Okay, and they given PZ max. They have given me PZ max equals to 30 millivolt. 30 millivolt. Okay, so PZ max for the diode, the maximum power it can tolerate is 30 millivolt. Okay, and PZ max is always equals to IZM into VZ. Okay, so now the current is coming here again. Yes.
Milli VZ, sir. 30 milli VZ. PZ max is equal to 30 milli VZ.
30 milliwatt. 30 milliwatt. Okay, 30 milliwatt. Now, can you tell me whether this diode is conducting or not conducting? Okay. And what is the value of IZ? Okay. So you need to find. So I'm calling this is a load resistance. So you need to find the value of VL. Okay. And this value, say this is VR. This is your VR across resistance. So you need to find VR. You need to find PZ, and you need to find IZ. Okay. So VL is what is the voltage across this load. Okay. What is the resistance across this resistance? What is the Zener voltage? What is the power of dissipated by Zener, and how much current is flowing to IZ? Okay. So what is the first step?
Conducting.
What is the first?
Sir, PZ maximum is what?
PZ maximum power the Zener can tolerate.
Okay, sir.
Okay. The first step is to find out whether diode is conducting or not conducting. Okay. So what should I do? I should remove this one.
Circuit.
Open circuit voltage.
Very good. I open this one. Okay. So now tell me how much voltage is coming across the. How much voltage is this? So you have total 16 volt. So you want V open here, which is equal to this one VL. This case, particular case. Okay. So V open will be how much? Your V open will be 16 volt divided by 1 kilo ohm, and 1.2 is 2.2 kilo ohm. This is the current, and multiply again by 1.2 kilo ohm. Okay, kilo ohm cancel. So you have 16. Okay, 16 into 1.2 upon 2.2. Okay, tell me how much is coming approximately.
8.727.
8 point something. Okay, so it's whatever. Okay, 17. Okay, so this is less than 10 volt. Okay, so when this is less than 10 volt, that means my diode is not conducting. That means it is in a reverse bias or forward bias? So diode is not conducting means it is now in
Reverse bias.
reverse bias. I will keep it open. Okay, that means it's not started conducting. So that means now my diode is in this somewhere here, this condition. It has not reached here. Once it will reach here, it will allow the current. So it is not allowing the current. That means it is like open. It is a reverse saturation current flowing. That means almost negligible current flowing. That means you can keep the diode as open. Okay, negligible current means you can assume there is no current. So this is open. Okay, now in open condition, this is my V open. This is equal to VL. So in question they are asking what is VL. So in this open condition, your VL is nothing, is V open. Okay, so VL is your 8.1117 kilowatt. Okay, so now what will be your VR? Okay, so remaining 16 is there. 16 minus 8.17. Okay, so your VR will be what? Your voltage drop here. Okay, and voltage drop here. So here you already know. So VR will be your 16 minus this is 8.17, na? 8.17. So how much will come? Tell me.
8.72, sir.
8.7 hai, okay. 8.7 hai, okay. So this is how much will come?
6.27.
6.27. Okay. Whatever. So this is 7.3. You're saying, no?
7.2. 7.28, sir.
7. Here 7.28, na?
Yes.
Here 7.28. Huh? Okay. So this is your VR. Now what is the value of PZ? What is the value of IZ? What is the value of IZ? How much current is flowing here?
Reverse
IZ?
saturation current.
Zero.
Zero. Okay. So I say almost zero. Very good.
सर इस
Hmm.
सर ये रिवर्स सैचुरेशन करंट नहीं आएगा?
एक्चुअली रिवर्स सैचुरेशन करंट होगा, पर उसको इस सर्किट के कंपैरिजन में हम नेग्लिजिबल मान रहे हैं ना, तभी तो हमने इसको ओपन कर दिया ना. भी अगर ओपन नहीं करते तो हम बोलते रिवर्स सैचुरेशन करंट जा रहा है, पर हम ओपन कर दिया इसको. हमने रिवर्स सैचुरेशन निकालने का तरीका है नहीं हमारे पास. ओके, क्योंकि करंट सर्किट में करंट मिली एम्पियर में है और ये माइक्रो एम्पियर में है, तो हम मानेंगे कि पूरा का पूरा करंट यहीं पे आ गया है. ओके
सर इस केस में हम वो जो फॉर्मूला वैलिड होगा इसमें, I equals to IS exponential, I equals to IS exponential. वो
नहीं लगाएंगे, वो जिना डायोड के लिए नहीं लगाएंगे. वो लगाएंगे भी तो कैसे लगाएंगे भी तो कैसे निकालेंगे. ओके, आपको ये वोल्टेज है, ये वोल्टेज लगाना पड़ेगा, वो निकालना पड़ेगा रिवर्स बायस में, और रिवर्स बायस में करंट तो वैसे ही माइक्रो एम्पियर में आएगा ना. ओके,
yes sir.
So for safe, मतलब for simplification, we are assuming this current is zero. This current is milliampere, so nothing will change if microampere current is going. Almost all current is coming.
Okay, sir.
Okay, so IZ is zero, and what about PZ? So PZ also zero, because PZ is BZ IZ. PZ also zero. Okay, so this way you have to check. Okay, now from this question, one thing is clear. Okay. So there should be a minimum value of RL here. If this RL is less than that minimum value, then this diode will not be conducting. For example, this 1.22 kilo ohm here is not sufficient. Okay, 1.2 kilo ohm is not sufficient. Let me change this 1.2 kilo ohm with my 3 kilo ohm. Okay, and this time you solve same problem. Okay, this is my diode. Okay, this is 10 volt.
VL भी 0 आएगा.
VL क्यों जीरो आएगा? VL तो VL इक्वल टू V ओपन ना, VL जीरो थोड़ी आएगा, बिकॉज़ सर्किट ओपन है तो आपको VL में तो करंट जा रहा है ना, जो करंट यहाँ जा रहा है वो करंट यहाँ जा रहा है, तो जो हमने यहाँ V ओपन निकाला दैट इज VL.
Okay sir.
Okay, now the same question you do it, okay, with 3 kilo ohm resistance. This time I have changed the resistance 3 kilo ohm. Okay, again you check what is V open.
2.8 volt.
12 volt.
Okay, I am removing this one. Okay, so 16 divided by 4 kilo ohm into 3 kilo ohm. So this is what, 12 volt. Now this time it is greater than VZ, which is 10 volt, isn't it? That means now this diode is conducting. So you have to replace this by a battery of 10 volt. Okay. Now once this is a 10 volt, once this is a 10 volt, this also fixed in, because they are parallel. So this also fixed 10 volts. So your VL automatically become 10 volt.
The VZ is 8 na sir, 8 point something.
VJ 10 volt है भाई. B
Oh,
open निकाला.
okay sir. Okay sir.
Okay. So VL is 10 volt. Okay.
If both are
Now
10 volt, how it will flow?
both 10 volt means which one both 10 volt?
And also it is on the left side.
So
10 volt,
यहाँ
right?
once the voltage is fixed here, एक बार यहाँ पर वोल्टेज फिक्स हो गया तो ये तो पैरेलल ही है, यहाँ पे फिक्स हो जाएगा वोल्टेज, तभी तो वोल्टेज रेगुलेटर है. You can change anything here. Okay, you can change anything current here, but here voltage will not change. That is external, that is load circuit. So your this diode is always maintain the voltage here. That's why it is a regulator circuit. Are you getting?
No, sir, actually means how it can
See, this 10 volt, they are parallel or not parallel?
parallel, yes.
So parallel voltage भी same होगा नहीं होगा?
It should be same. Understood,
Okay.
sir.
So this is the parallel, always voltage will change. Even though you change this voltage, if you change this voltage, what will happen? Here current will change. This voltage is fixed. This voltage is fixed. Suppose you make 20 to 10. So not that now here is what? Not 16 minus 10. You have 4 volt, isn't it?
So
Now
6
suppose
na
now,
sir. 16 minus 10,
6 volt. Okay. So now VR is what? Your VR is 16 minus 10. That is 6 volt. Now suppose you make this is 20. Okay. 20. So what will happen? Still this diode will conduct because it is conducting with 16. So it obviously it will conduct with 20, but also so this is fixed. This is fixed. Now whatever extra voltage you're applying, okay, that will come to here, and current will increase. Okay. Once current will increase, okay, IR will increase. This IZ will increase and IL will increase. Okay, but your voltage will maintain. Now once this is fixed, this current is also fixed. Okay. Once this voltage is fixed, this current is also fixed. Now if you're increasing voltage, what will happen? The current IR will increase, and IR will increase your Zener current, because I told you the circuit is like this. Your circuit, your IV characteristics like this. In same voltage drop, okay, you can have a current up to IZ max. So increasing the voltage will have effect. This current will increase. This will become fixed. This will increase if this is a fixed circuit. Okay. So that's why this is a regulator circuit. Output voltage will not change. Output voltage will be always 10.
Sir,
Huh.
here how we get VL equals to 10 volts, sir?
Which 10 volt?
VL.
These both are parallel, na?
Yes, sir.
Parallel voltage will always be same. Okay.
Sir,
हाँ.
voltage is installed, but current is how current
parallel में voltage same होता है नहीं होता है?
parallel understood, sir. Voltage will remain same.
हाँ.
But current, how it will be changed? Because if a resistance is constant, voltage is constant, current should also remain same, na?
If you're increasing this one, now suppose voltage regulator, what do you mean by regulator? Now suppose you have 16 volt. Now some fluctuation is coming in your circuit, external voltage. So this becomes 17, 15 is varying. If it is varying, but I should not get variation here. That's why what is the use of regulator? Regulator will give you okay, regardless what is happening, it's input. It will always give me a fixed voltage here. So now suppose fluctuation is 1 volt fluctuation, you have 0.5 volt fluctuation, so this becomes 16.5 volt. Okay, so this current will increase, but this current cannot increase because this is fixed. So this but this IZ can increase. So the effect of this one will be captured by this one. Okay, this will tolerate more current. This will take more current, but this current will fix. This voltage will fix. So you get at the output, you will always get a fixed regulation. Is that point is clear?
Okay.
Other
Sir,
student,
IZ increases, na? IZ increases.
obviously IZ increase. Something will happen. If you increasing voltage, this voltage fixed, this voltage you increasing. So obviously the increased voltage will come here. Okay, increased voltage will come here means this resistance fixed. So current IR will increase. Now IR will increase. So IR is equal to IZ plus IL. IL cannot increase, so IZ will increase. Okay, but we have to apply
Also-
voltage such that it should not go. It should not become IZ max.
Yes, yes, yes.
That's the thing. Okay. So
output voltage is constant, output correct is constant.
yes,
Only change occurs across zener diagram.
yes.
Correct.
So you have VL, VR. What else I asked? I asked what is the IZ. So in this particular case, what is IZ? In this particular case, what is IR? How to calculate IR?
IR minus IL. IR
6
minus
million.
IL.
So first I need to calculate IR. IR, how do I calculate? I should know the voltage here. Okay. So this 16 minus 10, I have 6 volt across. So IR is what? VR upon R. Okay. VR is 6. This is 1 kilo ohm. This becomes 6 milliampere. Okay. IR is 6 milliampere now. And IL is how much? IL is your VL. VL is 10 volt. Okay. VL upon RL. Now VL is your 10 volts. RL is 3 kilo ohm. So this becomes 3.3 milliampere. Okay. So how much IZ will come? So IZ will come.
2.66.
Okay. So IZ will come IR minus IL. That is, he's saying 2.67 or 66. Okay. Milliampere. And once you know the IZ, you can find your PZ also. So PZ will be what? PZ will be your IZ is 2.67 milliampere into 10 volts. So how much will come? So this was 26.7 millivolt. Okay. So let me do some other problem, one more problem. Okay. Now suppose I'm erasing this one. Now in the same circuit, okay, in same circuit, what we drawn here, 16 volt. Okay, here we have 1 kilo ohm. Here we have a Zener diode of 10. Okay, and here we have just put a load resistance RL. Okay, and this is 10 volt. So I shown you that when resistance was 1.2 kilo ohm, that time my diode was not conducting, isn't it? But as I increase the diode resistance up to 3 kilo ohm, my diode start conducting. So somewhere it should be a value, minimum value. Okay, there should be a minimum value so that my diode should conduct, isn't it? So I need to calculate the RL minimum value. See, just now previous question, when I put 1.2 kilo ohm, it was open. When I put 3 kilo ohm, it was conducting. Now in between there will be some value where it will be just closed, just conducting. Okay. So when I want to calculate RL minimum, so RL minimum is the value for that diode is just conducting. Okay. That means RL V open should be exactly 10. Earlier case, one case it was 8.7, other case it was more than 12.7 or 12 point something. Now, if you want to calculate RL minimum, you have to calculate V open, and this V open should be exactly 10 volt. If you want to calculate this one here, RL minimum, then your V open should be exactly 10 volts. Okay, V open. So this is V open. So I know what is V open formula. V open is 16 divided by this resistance R plus RL minimum into RL minimum. Okay, and this should be exactly 10. This becomes 16 R plus RL minimum into RL minimum. Okay, so solve this one. What is the minimum value for this circuit? So minimum value. So this becomes 10 R. Just 1 minute. 10 RL minimum. Okay, 16 RL minimum. Okay, so this becomes 6 RL minimum equals to 10 R. 10 is 1 kilo ohm. Okay, R is 1 kilo ohm. So you have RL minimum this much. Okay. So how much is coming? 1.6. 10 divided by 6. How much will come?
1.6 kilo.
1.6 kilo ohm. Okay, just let me check. Okay, yes, 1.66 kilo ohm. Very good. Okay, this will come 1.66 kilo ohm. Okay, so this is the minimum value that particular circuit should have in order to diode to make conducting. Yes, any question?
सर इसको हम मतलब 10 वोल्ट की बैटरी के साथ रिप्लेस करके नहीं कर सकते थे?
वो एक ही 10 वोल्ट की बैटरी पहले हम चेक कर रहे हैं वी ओपन. ओके, अगर 10 वोल्ट की बैटरी है तो हमने फिक्स कर दिया ना, फिक्स कर दिया हमने.
तो हम यही कंसीडर करके चलेंगे कि ये कंडक्टिंग है.
हाँ, जस्ट कंडक्टिंग. हम कनेक्ट हमको कंडक्टिंग बनाना है, तो कंडक्टिंग बनाने के लिए मिनिमम वोल्टेज कितनी होनी चाहिए, वी ओपन कितनी होनी चाहिए?
10 वोल्ट.
बस वही मैंने किया. ओके, व्हाट इज शुड बी द मिनिमम वोल्टेज? सो ये वोल्टेज डिपेंड है आरएल पे. अगर ये मिनिमम है तो ये भी मिनिमम होगा. ओके, आपने देखा क्वेश्चन में 1.2 था तो ये कनेक्ट नहीं कर रहा था, सीरीज कर रहा था. इज बिटवीन ये, दिस इज द मिनिमम वैल्यू. सो फॉर दिस इफ यू पुट दिस वैल्यू, okay, 1.66 kilo ohm, automatically your diode be open will contain 10 volts, so your diode will be just conducting. Are you getting my point? If this point is clear, so in a fixed circuit, you have to have, if you want diode connecting, this should be have a greater than this value. Okay, this should be your R minimum, so your RL should be greater than RL minimum, and it should be greater than 1.66. okay, how small? Suppose this is 1.66, now you 1.7, that is greater than 1.66. so your R load resistance should be greater than this RL minimum. Okay, equal you also can take, but when you equal take, then IZ will be 0. There will be no current flowing through diode. Okay, that is also approximately correct. Okay, but then your RL should be greater than anything greater, 1.67, 1.68, 1.7, but your RL should be greater than this one. Okay, is this point clear? Now suppose I'm giving you okay, now you have been given a circuit. Okay, here you have 50 volt fixed voltage you're applying, your R is 1 kilo ohm. Okay, you have this diode conducting, and here you have RL which I'm changing. Okay, IL. So you're asking, determine the range of RL and IL that will result VL being maintained at 10 volts. Okay, so this is given you, this is given 10 volts, and PZ max also given, IZ max given. This question they given IZ max equal to 32 milliampere. Okay, 32 milliampere. I'm writing here. IZ max is given 32 milliampere, and VZ is your 10 volt. Now you're asking, find the range of RL. Okay, find the range of IL, RL. Okay, RL and IL. Okay, that means you have to find RL minimum. Okay, and RL minimum and RL max. Similarly, you have to find IL minimum and IL max value. Okay, so how can I calculate? Suppose if I want to calculate what is RL minimum, so RL minimum, how can I calculate?
We open 50 volt लेके कर लेंगे.
Very good. Okay, just now we would solve for RL minimum. So RL minimum is simple. You have V open equals to, okay, 50 volt divided by 1 kilo ohm, that is 1000 ohm, plus RL minimum equals to RL minimum. Okay, you got RL minimum. How much is coming RL minimum? So this gives me RL minimum
0.25 kilo.
0.25 kilo ohm coming. That means we are getting here. Huh? क्या?
we open क्या लेंगे हम?
We open 10 वोल्ट लेंगे, 10 वोल्ट लेंगे. Okay, 10 volt. So you're getting 250 ohm. Okay. So once you know that you have RL minimum 250 ohm, so this is minimum. Okay. So when this is minimum, what will be IL? See, now this voltage is fixed. We are assuming this is conducting. So when conducting, what is the value
10
of
upon
R?
RL.
So this is RL minimum. So this will become RL max, isn't it? Are you getting or not? See, automatically when the voltage is fixed, resistance is minimum, so current will be
Current
max.
is maximum.
So IL max will be
10 upon RL.
10 upon RL minimum. Okay, so 10 RL minimum is your 250 ohm. Okay, so how much will come? How much is coming? 1 by
40
20.
milliamp.
4 million.
40.
Yes,
How much?
Yes,
40
sir.
milliamp. 40 milliamp. So this become your IL max. Okay. Now you know your IL max. Okay. Now I have to calculate what? I have to calculate now RL max and IL minimum. Okay. So how much current is coming from here? IR. How much current is coming?
40 milliampere.
40 तो ये है ना IL max है ना. Okay. So ये कितना? ये 40 है. ये 50 minus 10. Okay. This also fixed. Okay. So IR is coming your 50 minus 10 upon 1 kilo ohm. Okay. This is coming 40 milliampere. That means IZ is going 0. Okay. When you're calculating RL minimum, that time IZ is 0. So you have to slightly increase this one. Once you slightly increase this one, this will reduce and the current will flow here. Okay. So in this particular case, your IZ is 0 when this is RL minimum. Okay. So total current is your IR is 40 milliampere. Now I want to calculate the RL max. Okay. What should I do? I will to calculate RL max.
40
Okay.
minus 32 milliampere.
Very good. Okay. Now see, this is your IR. IR is always equals to IZ plus IL. Okay. Now if I want to calculate this IL minimum, so IL minimum is nothing, IZ max plus IL minimum. Okay. IR is fixed in this case. If voltage is fixed, this voltage is fixed, this current is fixed. This current will not change until you don't change this voltage. Okay. So now you want IL minimum. So IL minimum come your IR 40 milliampere minus IZ max is given 32. That is become your 8 milliampere. Once you know IL minimum, you can calculate RL max. Okay. When this is minimum, this automatically become max. Okay. So what is the value of RL max? So RL max will be your 10 upon IL minimum, which is 8 milliampere.
8.
Okay. How much is coming?
1250.
1.25
1.25 kilo ohm.
kilo ohm. Yes.
Okay. So this is the RL max. So we know now IL max and IL minimum value. So we calculate both the ranges. Okay. So I hope the question is clear. Any doubt in this question? Okay. So in this particular question, this is your 1 kilo ohm. This voltage is fixed. This current is fixed. They have given you IZ max. So once you know the IZ max, you know this current, you can find what is IL minimum there. Once you know the current IL minimum here, you know the voltage here. You can divide this 10 by, you can get RL max here. And RL minimum we already know how to calculate. by V open. Any question? So I'm erasing this one. Okay. Let me give one more problem. I have this battery. Okay, this time this battery is changing. V input changing from V minimum to V max. Okay, and here a resistance fixed 220 ohm. Okay, here we have a Zener diode here. Okay, and here you have here a resistance RL. Okay, which is fixed. Okay, and the voltage VZ is given 20 volt. VZ value is 20 volt, and they have given you IZ max also. So IZ max is 60 milliampere. 60 milliampere. IZ max is 60 milliampere. Okay. Now what they are asking a question. Okay. Find the V minimum and V max value. Okay. You have to find the V minimum and V max value. How much voltage should be there? I can apply max. How much minimum should be there? How much max should be there? So how can I calculate V minimum? Anyone?
सर आरएल का कोई वैल्यू नहीं दिया है?
RL का वैल्यू दिया है 1.2 किलो ओम. 1.2 kilo ohm. Okay. Now, what is V minimum? How can I calculate V minimum?
I maximum into R.
How much should be minimum value here? The minimum value here should be such that at least it should make this diode conducting. Are you getting my point?
Yes.
So this V minimum should be such that you should get V open equals to 20 volt. That much minimum you want. If you want to make this circuit if you want this circuit to work as a regulator circuit, so the minimum voltage here should be such that this should be conducting. That means minimum voltage should be here 20 volt. So V open should be equals to VZ if you want V minimum. And what is VZ? V open? Here they are given 20 volts, and that is equal to what? V that should be V minimum upon 220 kilo ohm plus 1 point. So this becomes 2.22 kilo ohm. Okay, 0.22 kilo ohm and 1.2 kilo ohm. Okay, so here I can find into 1.2 kilo ohm. That is 1 into 10 raised to power 3. Okay, or I can cut kilo ohm. Okay, this is 0.22, 1.2. So how much it become this one? Okay, so you have V minimum is equals to how much will come? 1.42 into 1.2. This should be 20 volts. Okay, so tell me what is the value of V minimum?
23.67.
Very good. Okay, it should come 23.67 volt. 23.67 volt. Okay, so once you know the V minimum, now you want to find out your. Now tell me, once this is fixed, okay, now this is V minimum. V minimum is you are fixed. Okay, now V max, V minimum, your any voltage should be greater than this voltage. You want to make this diode conducting. Okay, now we are going to calculate V max. Is this clear? This point is clear? Okay. Okay. Now I want to calculate what is my V max. Okay, what is V max? Okay. So for now, once this is conducting, how much current is flowing here? IL.
16.6 milliampere.
So you know IL will be how much? This is fixed on 20 volt. Once diode is conducting, this is fixed 20. So IL also fixed because this resistance fixed, IL fixed, voltage fixed, resistance fixed, IL fixed. So IL is 1.2 kilo ohm. Okay, this is coming around 16.
16.67.
16.6, very good. Milliampere is coming, IL is coming this much. Okay, and you know what is IZ max. So if you want IR max, so IR, how much maximum current flowing here? If it is this is maximum, this will be also maximum. Current will be changing this one, this fixed voltage, changing voltage this one, current will change. If this is a maximum, current will be maximum. So IR max will be now equals to IL is fixed. So IZ max is given, that will be equal to IZ max plus IL is fixed. Okay, now IZ max is given how much? 60 milliampere, 60, and this is your 16.67. So how much becomes 76.67 milliampere? This is your IR max. Okay, once you know this IR max, you can know what is VR max. Once you know the VR max, you can find V max. Okay, now how can you find V max? So your V max will be here simply equals to IR max into this resistance R plus this voltage. This voltage plus this voltage will be your V max plus your VZ. Okay, so now I know what is IR max. So IR max is how much? Just now 76.67 milliampere. Resistance is 220 milliampere, 220 ohm. This one, and VZ is 20 volts. Okay, tell me how much is coming.
So 36.86.
36.87, very good. 36.87 volt. So this is your range of B max, B minimum. Once you have fixed RL, then you can have a range of voltage VL minimum. Once you have fixed this one, you can have a range of RL. Okay, once you have fixed this one, you can have a range of this one, isn't it? So you have to do practice in such a way. I'll send the questions. So let me do one more problem.
Sir, Vmax तो जीनर ब्रेकडाउन वोल्टेज हुआ ना?
नहीं, जीनर ब्रेकडाउन तो चल ही रहा है. जीनर डायोड ब्रेकडाउन में काम करता है. जो VZ है, VZ आपका ब्रेकडाउन है. IZ मैक्स तो क्या है? जहां पे डायोड काम करना बंद कर देगा. डायोड विल बर्न आउट. क्लियर?
यस सर.
VZ पे तो जीनर डायोड ऑलवेज वर्क्स इन ब्रेकडाउन. ओके, now let me solve one problem. Okay. Now you have been given one circuit, okay, where the range is given 5 volts to 20 volts. Okay, this is changing. Okay, this is changing, and this is your changing 1 kilo ohm. Okay, this is your IL. Now find the P max versus P minimum value. Okay, and the resistance is given you 500 ohm. Okay, P max versus P minimum at the load. Okay, so how much is P max the load and P minimum the load? So you know power is what? Power is equal to your VI or V square upon R.
ब्रेकडाउन वोल्टेज नहीं दिया हुआ.
ब्रेकडाउन वोल्टेज दे रखा है आपको 10 वोल्ट. 10 volt. Okay, so calculate. How to calculate P max? So maximum voltage, how much can go here?
10 volts.
Any other student? How much maximum voltage can come here?
10 volts, sir.
Very good. Okay. So now so that's why you have P max how much? P max will be V square. P max is 10 volts. So 10 is, so first you have to check whether this is conducting or not conducting. So once you 20, it will be conducting. In 5, it will not be conducting. Okay. So the maximum voltage it can have, first case, 10 square upon R, that is 1 kilo ohm. Okay. That is, you will be having 100 upon 1 kilo ohm. Okay. That is 100 millivolt. Okay, 100 millivolt. And second case, so this is the हाँ.
कई बार हमने इसके पहले जो समझ किए ना उसमें हमें वी ओपन जो जीनर का वोल्टेज दिया उससे ज्यादा भी मिल रहा था मतलब
हाँ.
पहले मतलब एक एग्जांपल 10 वोल्ट तो उस
हाँ.
केस में मैक्सिमम 10 कैसे लेंगे
भी हमेशा 10 ही लेंगे ना, वही तो जनरल डायोड का रेगुलेटर है. वोल्टेज ड्रॉप जितना चाहिए उससे ज्यादा कितना भी हो वो वहां पे वोल्टेज फिक्स हो जाएगा. वोल्टेज फिक्स हो जाएगा, करंट बढ़ जाएगा. यही तो आईवी कैरेक्टरिस्टिक्स है कि वोल्टेज will not increase but current can increase. Okay. भी कुल मिलाकर ना मेन तो चीज यही है ना, भी आप वोल्टेज बढ़ा रहे हो तो कुछ ना उसको इफेक्ट होना चाहिए. तो वोल्टेज बढ़ाने से क्या हो रहा है, आपका रेजिस्टेंस कम हो रहा है, करंट बढ़ रहा है. बात तो एक ही है. तो यहाँ पे दैट वोल्टेज will maintain the voltage fixed but current will increase. Okay. So now this is your P max. For P minimum, what should I do? For P minimum, what I'll do, I will take this voltage as 5. Once I take this 5 volts, this will not conduct. This will become open. Okay, so this will be open. So I want to look what is the voltage here. So in that case, when your PL, at that case your VL will be okay. This is the VL actually. So VL will be how much? Your VL will be 5. Okay, 0.5 kilo ohm plus 1 kilo ohm. 1 kilo ohm into 1 kilo ohm. So this will become 5 upon 1.5 into 1 kilo ohm. 1 kilo ohm cancel. This become 50. Okay. So your voltage become how much? 5, 10 upon 3. 10 upon 3. Okay. So in this case, when the voltage is minimum, okay, when his voltage is minimum, you get minimum current here. Okay, minimum voltage here. So in that case, your P minimum will be now, okay, VL square upon 1 kilo ohm, and VL square is now your 10 to 100 upon 9, okay, milliwatt. So you want P max ratio. So P max upon P minimum will be 100 upon 9. That will come 9. Okay. This problem came in some exam. Okay. So this will be maybe JEM or NET. I don't know. Some exam came. So this is your answer. Clear? So if you have doubt, ask me. I'm stopping here. In this particular question, any question, any problem?
Sir, if
हाँ.
सर इफ
वो
VZ से कम वोल्टेज होगा तो ये ओपन हो जाएगा.
ये ओपन हो जाएगा.
ओके सर.
You have to check the open circuit voltage. Okay. तो obviously ये 5 है. हाँ, yes.
सर वो P मिनिमम के लिए हम 5 वोल्ट क्यों ले रहे हैं?
तो वही तो मिनिमम करंट देगा. अभी आप 5 वोल्ट निकाल रहे हो तो यहाँ पे कुछ करंट मिल रहा है. ओके.
यस सर.
आप तो अगर इसको 6 कर दोगे तो यहाँ करंट बढ़ जाएगा ना.
यस सर.
तो हमको करंट मिनिमम रखना है. जब करंट मिनिमम रखोगे अभी तो वोल्टेज मिनिमम होगा. अभी से 6 करते ही तो ये यहाँ वोल्टेज तो बढ़ जाएगा. तो हमको मिनिमम रखना है, इसलिए हम मिनिमम ले रहे हैं. भी ये 5 करोगे, 6 करोगे, 7 करोगे, 8 करोगे तब भी ओपन रहेगा, 9 करोगे तब भी ओपन रहेगा. Understand it is open. Somewhere when you are greater than 10, then sometime it may have voltage greater than 10 volt equal to 10 volt, then it's not conducting. After that, suppose it at 12 or 12, suppose at 15, at 15 it is conducting. So after that 15 you increase the voltage 16, 17, 18, 19, 20, but nothing will happen here. Here voltage will become fixed, because once it start conducting, here voltage will fix 10 volts, and your power max will be fixed. Okay, resistance is fixed, voltage is fixed, so P max is fixed, whether you have a 15 here, 16 here, 17 here. Okay, no issue. It should be greater than minimum. It should be greater than V minimum. V minimum means this is not V minimum, this is less than V minimum. V minimum is the voltage required to make this conducting. Okay, so that will be somewhere between this is 10 volts, this will be between 10 to 20 somewhere. Okay, so that is that is you would understand that one.
Okay,
सर
हाँ.
IZ मैक्स पे तो मतलब ये ब्रेक भी तो होता होगा ना जेनर,
वो
मतलब मैक्सिमम करंट अगर फ्लो होने
वो
लगे
maximum current value है,
limit.
that should allow, okay, for safe operation of diode. If you can allow maximum also, more than this also, but that will burn. So that is a security, that is a
Burn the
limit,
generator.
that is a limit. Yes, that is a limit of your Gino diode.
Okay sir.
Okay, I'm stopping. Thank you very much.
Thank you, sir. Thank you, sir.
So